Before we work sample problem 2.4, I want to go over the way we represent elements on the periodic table. They're often written with the symbol and the atomic number and the mass number. So normally it's like this. Oops. X is the symbol, and then we have this number A and this number Z, and those are written in numbers. Okay, so I'm going to point this out. This would be the atomic symbol. Alright, this A value would be the mass number. And then this number Z is the atomic number. So if you're looking on the periodic table, the atomic number is just the number that's listed above the symbol for that particular element. And so I highly recommend you looking in the book and kind of learning, all of these symbols and the names of them. You can find the entire list in the front cover, the very first page in the front cover of the textbook. So I highly recommend you going over those things and trying to familiarize yourself with these atomic symbols and the names of all of the elements. And so I talked about Z. That's the atomic number, okay, and that's also equal to the number of protons. And then the mass number A, that's typically close to the mass, the molar mass, which is also listed on the periodic table, and it is actually a sum of the protons and the neutrons which are contained in the nucleus. So, sample problem 2.4, let's read this problem. It says silicon has 3 naturally occurring isotopes: silicon-28, silicon-29, and silicon-30. Now notice here they've only given us the mass number. They haven't given us the atomic number. It says determine the number of protons, neutrons, and electrons in each silicon isotope. So atoms or elements on the periodic table, they can appear in nature as different isotopes, meaning they have different mass numbers or they weigh different, right? So let's see the number of protons. To do that, we can look on the periodic table and find the atomic number for silicon, which is 14. So I'm going to write silicon-28 first, okay, and I'm going to say that it has 14 protons, and we normally write that as P with a plus, superscript to represent, that's a proton. And then it asks how many electrons. So an element always has the same number of electrons as it does protons. So it has 14 electrons. Here, let me put a colon there so we know that I'm talking about this one. Alright, so then the last thing there is to figure out the number of neutrons. And so I'm going to go ahead and write this formula that I hadn't written up yet. And that is A, which is the mass number, is equal to the number of protons plus the number of neutrons. Okay, and we use the superscript of 0 for a neutron because a neutron does not have a charge of a particle. So if I want to know the number of neutrons, I can rearrange this equation, and it would be equal to the mass number minus the number of protons. So for silicon, that's going to be 28 minus 14, which would be 14 neutrons. Alright, so let's see, silicon-29, that's our next one. So let me write it down. Alright, so the atomic number did not change, so silicon-29 is going to have 14 protons. And remember, I told you that these things are going to have the same number of electrons as they do protons, so it's also going to have 14 electrons. And as far as the neutrons are concerned, what are we going to do? We're going to say 29 minus 14 this time, and we're going to have 15 neutrons, and that's always the case whenever we're talking about isotopes. The number of protons and electrons are not going to change. The one that changes is the number of neutrons, so that's the one that adds mass to these different isotopes of all of these elements. So let's see, the last one here was silicon-30. Alright, and so again we're going to have 14 protons, 14 electrons, and then this time we're going to have 16 neutrons, right? Because 30 minus 14 is equal to 16.